Okay, ladies and gentlemen, I'm so sorry. I'm trying to get this taken care of. So sorry it's late. Okay, here we go. Basic balancing equations tutorial. This is for non-redox reactions. When I'm talking about non-redox reactions, I'm talking about something a little bit more than we want to get into today. So I am just talking about basic balancing. Many of you expressed some interest in finding out more about that. So that's what I'm getting ready to do. I'm trying to get my pen ready so that I'm all ready to go when we get there. Okay. Computer's been freaking out a little bit. So basic balancing. You write the correct chemical formulas for the reactants and product side. That's really important. If you don't write the correct chemical formulas, then we have a problem and you're never going to get it balanced. So that's important. Then we created a T-table for the reactant side and the product side. Very simple, like an XY T-table. We list the elements or parts on each side, and I'll talk to you about what I mean by parts instead of elements. We tally the number of each element or part on each side, and then we use coefficients to make the numbers on each side equal for each element or part. What that means is that carbon on both sides has to be the same number, but carbon does not have to be the same as hydrogen if they're both reactants. They can be different, but the hydrogens have to be the same and the carbons have to be the same, but the carbon and the hydrogen do not have to be the same. Okay, so I'm bringing myself back if I can see my little thing. There we go. Here we go. So the first example that I would like to show you, is this one. S8 plus O2 yields. I'm having a little technical difficulty. Yields. Okay. SO3. Okay, so there we have the equation. Now I'm going to draw my T-table. There's my T-table. I'm going to do R and P for reactants and products. I'm going to list S, that's one of our elements. O is another one of our elements. We have 8S on the reactant side. We have 2O on the reactant side. We have 1S on the product side and 3O on the product side. So I look and I see S is not balanced. I've got 8 and 1. So the first thing I'm going to do is multiply this guy by 8 to get 8. That means the 8 goes in front of the SO3. The 8 goes in front of the SO3. Yeah, it's not happening because things are acting funny again. Okay, there's the 8 in front of the SO3. That means the O also changes. So we go 8 times that, and that gives me 24. Okay, so now 2 and 24, how do I balance that? Well, that's pretty simple. 12 times 2 is equal to 24. The 12 goes up here next to the O. Now I have 8 and 8 sulfurs. I have 24 and 24 oxygen. I'm balanced. The coefficients of balance equation are 1, 12, and 8. Pretty simple so far, right? So let's see if we can go to another example. All right, this is a decomposition example, just showing you, also reinforcing what we talked about. NaNO3 yields, and this is where we messed up last time. Okay, it's NaNO, yep, it's not going, O2 plus O2. So this is what we get here. So we, again, T-table. Okay, we have 3 things. We have Na, we have N, and we have O. Okay, we have 1 Na over here. Oh, I forgot reactants and products. Just to help keep us tracked, we've got 1 N and 3 O's. On this side, I have 1 Na, 1 N, and I have 2 plus 2 O's. Okay, so I'm going to try to see if I can balance this. So here we go. 1 and 1, 1 and 1. We don't need to do anything with that. And then we're looking at this. I've got 1 over here, and I've got 2 over here, and I've got 2, and I've got 4. So what can we do? So basically, because this is odd and the other side is even, the reactant side is odd, the product side is even, Yes, I made a mistake here. Hang on, let me see if I can correct that mistake. All right, let's try this again. Okay, no, that's still not the right one. I tell you what, I'm batting 1,000 today. Okay, let's try this again. Okay, products. So when you've got an odd reactants and even products or vice versa, what I tend to do is I tend to double the odd. Because if I double the odd, I know it's going to go even. So now I've got 6. That means I put a 2 over here in front of the NaNO3, which means I'm going to put a 2 here. I'm going to put a 2 here. Now, I can see my oxygens are really complicated. I know I'm going to have to go back up and fix Na and N, so I'm going to go ahead and do that. 2 and 2. Well, how do I know that? Well, because I'm going to put a 2 right here in front of the Na. Sorry. Yeah, it's being contrary today. 2 right there, okay. That means it also changes this first O. So I'm going to come down here and do that. Well, 2 times 2 is 4 plus 2 is 6. So there we go. 2, 2, 1 balances that equation. 2, 2, and 1. Pretty simple. Okay, let's try another one. Here we go. This one is an example of a, let's see, I had one pulled out. Let's do a combustion reaction. A combustion reaction in the sense of a hydrocarbon combustion reaction. I have to be really careful because I tend to say combustion reactions are one specific kind, and they're really not. That's supposed to be an 8 plus O2 yields C. I think maybe my finger is losing its touch. CO2 plus H. Sorry, it's taking me longer. I don't have a stylus, which is what I should have. Okay, so this is what we have. So again, we go to drawing the T-table. Here's our T-table. We have carbon, we have hydrogen, we have oxygen. We have 3 carbon, 8 hydrogen, and 2 oxygen on the reactant side. The product side has 1 carbon, 2 hydrogen, 2 oxygen, plus 1 oxygen. Now you notice I do this. I do this because I find that if you don't, when you're new and when you're trying to figure it out, what happens is you forget that they're in 2 locations. So when you change one, you change both, and then you never get things balanced. I feel like if you do this plus sign to show that they're in different places, that you remember they're in different places, and so you think, oh, well, it's not that one, it's this one, and you don't tend to make that mistake. So if we look at this, we see that carbon is 3 and 1, so we're going to multiply that by 3, and that's going to be 3. So we put the 3 in front of where the C is on the reactant side. That's having an issue. 3 right there. That means this first O is going to be multiplied by 3. All right. So we have 8 and 2. Okay, that's pretty simple. That would be a 4 change, right? And I get 8. So the 4 goes up here. Again, it's freezing at the top. I'm not sure why. 4 right here. And that means it also changes this guy to a 4. So now I have 3 times 2, which is 6, plus 1 times 4, which is 4. I have 10 O's. Well, that makes my life easier. It's an easy number. An even number means that all I have to do is divide it by 2 to get the number I need over here. I need 5 oxygens. Okay, so I put the 5 up here with the oxygen. So let's say 3 and 3, yep. 8 and 8, yep. 10 and 10, yep. So now it's balanced with a 1, 5, 3, 4. Well, yeah, 4. There you go. Okay, let's try another one. I'm going to jump into the scheme of double replacement really quickly because I want to show you something that is kind of important when you're doing this. Let's see what I've got here. All right. Okay, let's try this one. I have AuOH3 plus Na2. Yes, here we go again at the top. Na2 CO3, and that's going to yield, remember double replacements, they switch partners, that's going to yield AU2 CO3, and we got to put parentheses because we have 3 of that group, plus NaOH. Okay, so there we go. So now we're going to make our T-table. Here's our T-table. We have the reactant side, product side, and now I'm going to write what I have down. I have gold. I have hydroxide. The reason I can do this is I can see there's a hydroxide here and there's a hydroxide here. Because it's together on both sides, it doesn't change, it doesn't break apart into anything, I can keep it together. Then I have Na as an element, and I can do the same thing with CO3. Because I have one here and one here, I'm all good. So how many Au do I have? I have 1. How many OH? 3. Na, there are 2. CO3, there are 1. If I go on the product side, I have 2 gold, I have 1 OH, 1 Na, and 3 CO3s. So I'm looking at this and I'm saying, okay, so I need to 2 and 1, I need to multiply by 2 here. All good, that's 2, so that 2 goes in front of where the Au is right there. It changes the OH. See how Au right here is with the OH? Okay, so I'm going to multiply that by 2, and I get 6, and I'm going, okay, well 6 and 1. That means I have to multiply this guy by 6. The 6 goes in front of where the OH is on the product side, which is right here. That also changes the Na. 6, 6. Oh, that means the Na, okay, I've got 2 here, I've got 6 here, that's 3. And remember, I'm just doing least common multiples. This is pretty simple compared to some of the math that you guys have done before. I multiply this by 3. Oh, I don't have to do any changes right there. So I've got 3 and 3, 2, 2, 6, 6, 6, 6. Notice how they are not all the same number, but 2 of them are the same. The rest of them are not. So the coefficients are 2, 3, 1, 6. Pretty simple. Okay? So I think that we'll stop here. I'm going to show you a little bit more about the whole idea of net ionics tomorrow, and we're going to practice that. And we're going to be working on Monday on some other stuff. Thank you.